So today we've been coring a small pond here in Tromsø. It's approximately 7 meters down we've been with the corer through all of the water column and down into the sediments. And why we do this is to collect sediments or the clay, the mud from the lake floor that we use for climate reconstructions. Ponds or lakes, they are really good for this kind of studies because they are depressions in the landscape and they trap all the material from the landscape. So it will be inwashed with snowmelt and with the rain, and everything, all the smaller particles will be collected on the lake floor. So it's like a climate archive preserved in the lake. Usually we take several cores and we can have them overlapping, so we cover all of the time where we have sediments in this lake. And then we bring them back to the lab so we can study them further. So here we have a sediment core that we've been collecting from this little pond. And what we can see here is something we think is really interesting because you can see different types of sediment. So we have this clay stuff in the bottom, the bluish gray one, and then we have some more brownish organic material on top. Here in Tromsø we used to have a glacier. Approximately 12,000 years ago it started to disappear. So these sediments here, the clay, that's deposited by the glacier and tell us that we had the end of the last ice age. Yeah, so we cut the clay now to see if we can see some structures in it or if we can see some other information that we can't see from the surface.
There's actually some silt and also some sand grains. We taste it and you can hear the sand grains on your teeth. And then this is the transition from the ice age with the position of clay and silt, and then the organic sediments start to accumulate around here. We can also see, if we have a closer look into this organic sediment, that there were plants growing on land around the lake here. These are leaf fragments, or actually whole leaves. These could be from birch or from other trees growing around the lake.
Yeah, and this is from really deep down in the core. So we know that these trees were growing here just after the last ice age. So they might be 10,000 years old or even a bit more. Yeah, so this is the treasure hunt of a geologist, trying to find these things. So when we find these, we're very excited. It might just look like, some leaves, but for us, they are really useful.
These are some of the best, probably the most well-preserved leaves that I've ever seen in a sediment core. These are like, 10,000 years old leaves. They look like they just fell last winter. You can have a look at them. It's fantastic. Just take it.
For me, days like this are the best when you're out in the field, look at material, spending a lot of time later on in the lab, then trying to remember this day and what we did is really helpful. Yeah, it's always good to be out.
Yeah, so here we have a marine sediment core. It's actually a tube from the seafloor. So you can see that in the bottom here, it's the oldest. And you go up as the age gets younger. And we are here in the top. Here there's actually some plastic in the top part. On this table, you can see all the different layers represented. And you can see that there's a different environment connected to the different layers. So for example, starting with the bottom layer, you will have lots of different gravels and sand and all kinds of grain sizes. And that's because the glacier was actually pushing the sediment off the continental shelf And once we go higher up in the core, we come to this very fine-grained sediment. And there's also these microfossils, but here in a very big size, so that you can actually spot the difference. And they are actually being brought out by these icebergs here, coming up from the shelf. If we move further up, closer in time to now, then you can see that we have this clay sediments. There's a lot of it here, and that's because the glacier melted back really quickly. If we move to what looks more similar to what we have this present day, it's also fine-grained sediment, but it's more organic material in here. And now, here is all the plastic included in that similar deposits.
These are foraminifera. Foraminifera are very useful organisms that live on the ocean of the whole world. They can be either benthic and they look like more flattish and they live on the ocean floor, or they can be planthic and they live floating on the ocean. They are very useful because they build this calcite shell that keeps the chemical composition of the seawater. What we can do is look at the chemistry, for example, and find out how the ocean was in the past. I think I got lost. Does people understand micrometers? Okay. When we go to the ocean and we look for these organisms, we usually look at this kind of sediment. As you can see, it's very, very, very fine. And to study this, we need to use a microscope. One of these grain of sand is bigger than one of these guys.
Are there actually forams in it?
No, it's fake. If you look at a lake core, if it had been marine before, you can actually find these shells in there. And you use the similar procedures when you look at a lake core. And they also date stuff, but they normally date like organic material that you can see around the lake. But in the ocean, we have to use these foraminiferas or microfossils that we date. So yes, we can actually read the climate from sediment core that we retrieve from the seafloor.